Once, good to see you again. How have you been? Testing, testing, probando, probando, uno, dos, probando. ¿Cómo estás? ¿Se oye bien?
Yes, mister.
Ok, déjenme cambiar headphone, record. Ahora sí. Otra vez, alguien que me diga, hola, 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 probando, probando.
Hola, mister.
Ahora sí. Sí, es que la entrada de audio mía estaba por el poli, no se escuchaba por el auricular. Okay, guys, today we're going to learn how to factorize the polynomials. Just hold on a second. Sorry. Okay, guys. Today we're going to learn how to simplify algebraical expressions for this situation. We're going to learn how to use the factorization of polynomials. This is going to be the name of the lesson. Okay. Factorization of polynomials. Okay. So in the last class, okay, we're identifying what will be some kind of formulas to try to reduce at the moment we're going to multiply the binomials. We're talking about the same nature, the same class. In that name of the formula that we'll study the last class, but we're talking about the special products. Okay. We got this formula, but I'm going to copy once again because I really want to prepare a little review on those special formulas. These special formulas are given by, for example, a plus b second power, a squared plus a2b plus b squared. Second, a minus b will be a squared minus 2ab plus b squared. The another special product was a plus b cube power will be a cube plus 3 times a square b plus 3 times ab squared plus b and q. And finally, we got the last special product, a minus b equals a squared minus 3 a square b plus 3ab squared minus b in third power. That was the formula that we learned two classes ago, how we can obtain or calculate the special products. Those formulas are used just to simplify the process in the multiplication of binomials when we have the same term. Okay, do you remember how we can apply those formulas? But this is to simplify at the moment we're going to multiply or to provide an expansion. But how about if we got some kind of polynomials, then instead to extend the polynomial, we have to reduce the polynomial, okay? But that situation, because we have a special product, we have some kind of special formulas for factoring. Why so useful this special formula for factoring? Well, this special formula for factoring, my dear students, are designed to simplify some kind of algebraical expressions in one singular event. Let me give you the special formula for factoring. We have three cases, special cases. The first one is what we call difference square. A square minus b square. Why the name different square? Because we have a subtraction, okay? In two terms elevated to the second power. If you see, this is a huge difference between this blue one with the second black one, okay? Don't confuse, this is not the same. A minus b second power is totally different than a square minus b square. This Formula for factory can be reduced multiplying by the first factor, a minus b times x plus b. Sorry, a plus b. If you see, we're going to multiply by himself. However, taking the opposite sign. The first one negative, second one positive, or if you wish, the first one positive, the second one negative. Remember, the order of the factors doesn't affect the final result. Remember, it's totally different, this one, with the second black one. It's two different. Don't confuse that situation. We have another special formula for factoring. This is what we call addition of cube. A cube plus B cube. If you see, it's totally different than the third one. It's different because a plus b elevated the third power will be the entire term, and this is only the letter a, and this is going to be only the letter b. How we can expand this special formula for factoring is given by the equation a plus b parentheses a squared minus ab plus b squared. Yeah, this is a negative sign. I know there is no number two. I know, but this is the special formula for factoring. This is addition of cube. And we have a third special formula factory. This is going to be difference of cubes. Okay, a cube minus b cube will be the same. But what will be the difference? The position on the sign will be different. I mean, instead to set a plus b, we got a minus b. And this is going to be a square plus ab plus b square. Okay, we got the special product is using to say simplementary words, simplify the process when we have to multiply binomials with the same value. And another one, the special formula from factory I'm using to simplify polynomials. We're going to learn how to simplify the polynomials with addition, subtraction, product, and division. Okay. And what about what happened if we must factorize some kind of special, some kind of polynomials, and they're not accomplished the shape of these three blue one formulas? Well, in that situation, we can apply one singular technique that you'll learn around in fifth, sixth, seventh, and even done in eighth grade. In that technique, in that situation, we can call that one like a greatest common factor. Okay, do you remember the greatest common factor? That's supposed to be percent in all terms, and we're supposed to take that smaller one, right? Well, actually, the same happens in the factorization of terms. So instead to call greatest common factor, we can call that one common factor. But basically, the operation will be the same. And there is no formula. The only thing that we have to do in that kind of problems is see the polynomial, prepare an observation, and after that, apply the common factor wherever is necessary. Sometimes we can take a common factor at once, or sometimes we have to grouping in couples, selecting couples to factorize the terms. Okay, so before to continue, because actually the only thing that I made in that situation is copy the formulas. But before to continue, do you have some questions into this part, or everything's clear, guys?
So the formula are the same as the special products because we don't answer this, so only we simplify it, right?
Yeah, the second ones are using to reduce polynomials. And the first one to simplify the process to multiply binomials when they have the same value. Actually, you said you used that word in the last class. Do you remember? And that's right. Okay, that common sense is using to how to say that to reduce the process. At the moment, we're going to how to say that apply the terms. Okay, so let me give you one singular example. Okay, In example number one, factorize the following polynomials. Okay, we're going to factorize the following polynomials. Okay, let's going to start with the first one. Letter A. I'm going to give an example with an easier one. Okay, just for because this is the beginning. Um, let's see for a single example. Let's see what we got. Yeah, this will be nice. 15x to the 4 power, 15x to the 4 power, and 15x to the 4 power minus 5x cubed minus 5x cubed and minus 5x cubed and plus 20x squared. Okay, and we have to factorize this expression. If you see, when only seeing that expression, we cannot use in that special formula for factory because if you want to compare the shape of the polynomial with the shape of the three blue ones formula, there's totally different, right? When that case happens, we're going to use the common factor or the greatest common factor. In this situation, remember, when we're talking about the numbers, we have to calculate what will be the common factor or the greatest common factor of the numbers 15, 5, and 20. Okay, what would you like to tell me what it is? The greatest common factor of 15, 5, and 20? The number 5, right? Because all of them are multiples of 5, and 5 is the number who has the less degree, right? The smaller one. Okay, we're going to obtain the number 5. And how about the letters? We have x4 power, x cubed, and x squared. So same rule happen. What will be the smaller value of the letter x?
X2.
X squared, right? Is the small in degree, right? Well, I'm going to copy the small in degree over here, x squared. Now what I'm going to do, I'm going to open parentheses and check this out. I'm going to divide the three terms. I'm not using long division. No, 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 no division. No, just divide normally every term by the term that we take it outside. Okay, for example, 15 divided by 5 will be 3, right? 3 what? Remember, x in which power? No, we have to copy the base and subtract the powers. Remember, 4 minus 2 will be 2. Understood how we got the first one?
Yes, mister.
All right. How about the second one? Negative 5 divided by 5 is negative 1. Well, you don't need to copy the number 1, only the sign, the negative sign. And we have x cubed with x squared. We're remaining one singular letter x, right? So we need to copy the letter x. And finally, 20 divided by 5, 4, and x squared with x squared cancel. And we have the factorization of this first term. And this is how the common factor works. Common factor or greatest common factor. If we have the numbers, I know I'm skip the process how to calculate the common factor because you know how to calculate the greatest common factor numbers. In the letters will be easier for us because you're going to take only the smaller one. All right. Let's going to do another example. If you don't understand, let me know, guys. Okay. We have the letter B. Whew. We have 20x cubed y cubed, 20x cubed y cubed, okay, plus 6x squared y4 y4 power. And obviously, the another one will be negative 12. Negative 12. Uh, negative 12 x y fifth power. Okay. So, guys, uh, same happened. Could you like to tell me what will be in the numbers 26 and negative 12? What will be the greatest common factor?
Two.
That will be the number 2, right? Because all of them can be divided by the number 2. Perfect. Bueno, eso quiere que aprendieron bien el año pasado. Los felicito. We have the number 2, all right? And how about the letters? We are going to take the letters who has the degrees lower power. Okay, for example, the letter X, the lowest power will be X, the last one, right? And how about the letter Y?
Three.
Y3 power. Okay, now what I'm going to do, I'm going to open parentheses and I'm going to divide every term by the common factor. 20 divided by 2 will be 10, right? 10 what? X squared, and the letter Y disappear because y cube cancel, right? The another one, 6 divided by 2,
Three.
that will be 3, right? Okay, 3. And if you see x squared with x, we have only x. Y4, y, that will be y. And finally, negative 2, sorry, negative 12 divided by 2, there will be
Six.
6, right? And if you see the letter X disappear, right? Because it cancel. But Y fifth power, Y third power, that will be Y second power. Okay? Y second power. And this is going to be the solution set of this common factor. All right? This is how we're supposed to apply those rules, those numbers. Okay? And sometimes we have to regroup a strategy, how we can solve this common factor sometimes. Just like, for example, in this letter C, in the letter C. For example, if I have 9 parentheses, 2x minus 5, okay, 9 parentheses, 2x minus 5 plus 6 parentheses, 2x minus 5 second power. Remember, I'm not saying we have to solve it multiplying after that. No, no, we have to factorize. Okay, first of all, what is the common factor between the numbers 9 and 6?
2x minus five.
No, no, the numbers 9 and 6. What is the common factor? The number,
Three.
that will be 3, right? Okay, 3. Now, what is the factor who's repeat? 2x minus 5, right? Because the smaller one is this. So I'm going to copy 3 parentheses, 2x minus 5. And if you wish, I can use a bracket because I don't want to use another parenthesis because we are using parentheses already, okay? Now let's going to proceed to perform the same operation. For example, 9 divided by 3, 3, right?
Three.
3. And 2x minus 5 divided by 2x minus 5 disappear. So you got only the number 3. The next one, positive 6 divided by 3 will be positive 2, right? And how about 2x minus 5 second power divided by 2x minus 5? Cancel 1 degree, okay? And will be parentheses 2x minus 5. And close parentheses, close the bracket. Understood until this far or no?
Yes.
Okay, now I'm going to leave the outside special just like this one because The main purpose is trying to factorize, but inside the brackets, we have to reduce that expression, okay? Inside the brackets. I mean, 3 parentheses, 2x minus 5, open bracket, and we got 3 plus 4x minus 10. And instead to use the bracket, now we can use the parentheses. And we got 3 parentheses, 2x minus 5 parentheses, 4x minus 7. Okay? And we finally factorize the expression. Okay? Because basically, the main idea is not adding, subtracting, multiplying, divide the like terms. The main idea is simplify the expressions. But we cannot leave the common factor like a 3 plus 2 parentheses 2x minus 5 because there it is not simplified yet. All right. That's why inside the bracket, we are applying like terms and reduce those terms. Yes, Gustavo?
So we only when so the process finishes when the factorization is simplified, right?
Exactly.
Because if there
Exactly.
are brackets, we need to simplify the
Inside the
process inside
bracket.
the brackets.
Yeah, and actually I'm use bracket because this is a nilty way to see the process because use a huge parenthesis inside another parenthesis don't like it at all. So we have in math another resource or another tools to remarkable the process, right? So did you understand how we're going to apply the common factor, guys? Yes or no?
Yes.
Yes.
Okay, let's going to do another one. Another one. This is going to be just a little bit complicated. All right then. I'm going to move the camera a little bit to the right. Okay. Okay. Pay attention because this is going to be a little bit more complicated. For example, we have in the letter D. In the letter D will be 10m squared, 10m squared. Okay. 10m squared, 10m squared minus 12mn minus 12mn. Okay. Uh, minus 25mn minus 25mn. And finally, 30m squared plus 30m squared. I know you're going to say, but mister, we have to factorize this expression, but we can perfectly reduce light terms in the middle ones. Hey, you're right. In the middle ones, that will be a light term. But remember, the main purpose in this situation is applying the factorization rules. Even though you have light terms in the middle one, we're going to proceed using the factorization technique. And you're going to say, but this is not all of them. They're not common factors, only one singular couples, right? For that reason, the name of this factorization that we call like a name of grouping, because we're choosing the couples who has a one common factor sense. For example, in the first one, in the first couple, we have the common factor in the letters M, right? And we can obtain the greatest common factor between 10 and 12, right? So would you like to tell me what is the common factor in
Two.
10 and 12? That will be number 2, right? 2. And after the number 2, the factors repeat with the less frequency, the letter M. I'm going to avoid the letter N because only present in the second one. Open parentheses, and you know, these two terms divided by 2M. 10 divided by 2 will be 5. 5 what? 5m. Negative 12 divided by 2, 6. And m with m cancel, and we got only the letter n. Okay. Now, in the second one, common factor between uh, 25 and 30, that will be the number 5. And because we have a negative sign outside, okay, I'm going to copy the negative side in the number 5. How about the letters? In the letters, what will be the common factor?
And
The letter N, right? Because N is present between 25 and 30. All right, perfect. Open parentheses, and now let's going to proceed to performing the same situation. Negative 25 divided by negative 5, that will be 5. 5 what? 5m, right? Because, oh, sorry, n. 5n, okay? And how about with the second one? Okay, in this situation, we got 30 divided by 5, that will be 6. For this case, will be, yeah, m, this m, yeah, will be negative 6 n, right? Right? Yes or no?
yes, Mr.
Okay. So is this finished or not? What do you think? Why is minus? Because if you divide 30 divided by negative 5, it's negative 6. That's why. Is this finished or we can continue simplify this expression, guys? What do you think?
Way to simplify.
We can simplify more than that because if you see 5n minus 6n is repeat here with this one, right? If the same, so we can obtain once again the common factor. But what will be the big deal in this case? It doesn't matter which one I'm going to choose because both have the same degree. So I'm going to use 5n minus 6n. Open parentheses, and it's going to proceed performing with the same factors. I mean, these two terms divided by this one, cancel, and we're going to obtain 2m, right? And finally, these two terms divided by this one, the answer will be negative 5n. And that's it. That's all that we have to do. Solving by grouping. ¿Qué tal? Did you understand? Yes, Gustavo?
So we first group it separately, and then we use this
Simple division. Simple division.
simple division.
I'm not using long division. I'm using one singular, simple, regular division. Okay, that's why. Well, let's going to perform another example. If you see, we are not using yet the special formula from factory because I'm focused first how you're going to identify the common factors. And after that, we're going to learn how to use the special formulas because it's the special formula that will be easier for us because those formulas are easy to identify which one will be the chosen one. So I'll give you an example. All right, we have this one, the letter E. We have, let me see, uno bonito, precioso. Yeah, we got this one. AX squared, AX squared, okay? AX squared plus 2AX, 2AX, all right? Minus 3A. Oh, minus 3A plus BX squared bx squared, bx squared plus 2bx plus 2bx minus 3b minus 3b. Oh, what we gonna do? What we gonna do when they come for you? What boys, bad boys? What you gonna do? What you gonna do when they come for you? Okay, so what will be the strategy? We're going to grouping, right? Because I know the letter X represents the first two terms over here and the first two terms over here, but not necessarily the entire equation. However, if you analyze the letter A, it is present in the first three terms, in the letter B, in the last three terms. So we have to obtain the common factor by grouping. For example, in the first three terms, obviously, the common factor will be the letter A, right? And we got x squared plus 2x minus 3, right? Because remember, every part of the equation must be divided by the letter A. By the other hand,
It will be the same as 1A, right?
mhm, and by the other hand, we obtain B, and we got x squared plus 2x minus 3. Yes or no?
Yes.
And finally, we can obtain once again the common factor. And what will be the new common factor? X
X
squared plus
squared plus
2x
2x.
minus 3. It doesn't matter which one we're going to take because both have the same degree. No problem with that one. Okay, x squared plus 2x minus 3 parentheses a plus b. And that's it. Okay. In a few lessons later, after we learn how we can use that special formula from factory, I'm going to teach you how to solving this quadratic equations. This is like, for example, x squared plus 2x minus 3, because we can continue factorize this expression. But in a couple lessons later, for example, if God wills on Monday, perfectly, you're going to learn how to use these three special formulas, and I'm going to teach you how to factorize the trinomial of perfect square. You're going to identify because it had three terms. The first one is a quadratic expression, the second one is a linear, and the third one is an independent term, just like that example, x squared plus 2x minus 3. But don't worry, on Monday, I'm going to teach you complete this, just like Darth Vader says to Luke
Look.
Skywalker, Luke Skywalker, don't worry, Luke, the the circle will be complete. Entonces falta todavía completar el círculo. Bueno, entonces antes de despedir la clase, ¿estamos claros cómo se utiliza el factor común?
Yes.
Perfecto. Aquí en la clase estamos claros, factor común. Diego, claro, factor común. Excelente. Bueno, entonces mis estimados aprendices, lo vamos a dejar hasta aquí por el día de hoy. Entonces el lunes continuamos ya con Special Formulas for Factory. ¿Las copiaron, por cierto?
Yes,
¿Copiaron las
mister.
fórmulas?
At least
Perfecto,
me.
miren. Por cualquier cosa, aquí están, ¿bien? Y le hacemos un cachito para atrás para que nos miren bien. Y ahí está la pizarra completita. Bueno, Dios los bendiga, los guarde, los cuide. Los veo el lunes, si Dios así lo permite, porque mañana no hay clase. Mañana no hay clase, mañana no hay clase, mañana no hay clase. Hasta- Dele, cuídense.